Hello, today we're going to review factoring so that we can then learn how to complete this square to then help us with our equations of circles in the next coming weeks. So let's review our factoring. If I asked you to factor number 1, we want to first see if there is a GCF. So when we think about factoring quadratics, remember our standard form is ax squared plus bx plus c. And so our steps of factoring, if you recall from a couple weeks ago, we take, after we look at our GCF, which number 1 does not have a GCF, our a is 1, our b is 6, and our c is 9. And since there is no GCF, then we go to step 2, and step 2 is to take your a value times your c value. So 1 times 9 is 9. So then what we do is we find all of the factors that multiply to 9. So 1 times 9 gives us 9, and 3 times 3 gives us 9. And we look at those pairs and we determine which ones will add to our b value of 6. Well, 3 and 3 add to 6, so those are going to be our values. Now when your a is 1, we have what we call a shortcut to get to our factors quickly. So because a is 1, we can write it, we know that when we factor, we're factoring it into two binomials. So if we have an x here and an x here, that's how we're going to get, when we write x there and x there, that's where that x squared is coming from. So we have our x and our x, and then all you have to do is take your 3 and 3 that you found that multiplied to 9 and added to 6, and you put that within your binomials. So this factors to x plus 3 times x plus 3. And notice they're the same. Because they are the same, we could rewrite that as x plus 3 quantity squared. And those are your factors. Let's take a look at number 2. Again, notice our a value is 1. So we're not going to have a GCF, so we're going to take a times c, which is 25. And we're going to find those factors of 25 that are going to add to our b value of 10. Well, 1 times 25 and 5 times 5. Well, 5 and 5 add to 10 and multiply to 25. Because a is 1, we can do our shortcut method. So we know we're going to have our two binomials. So it's going to be x plus 5 and x plus 5. And because they are the same, we can write this as x plus 5 squared. And there are your factors. So if we take a look at number 3 is saying, again, our a value is 1, so we want to multiply to 100, but add to 20. So if we think about our list of 100, it goes for a while. We have 1 and 100, 2 and 50, 4 and 25, 5 and 20, and 10 and 10. So which pair adds to 20? Well, 10 and 10 do, and because our a is 1, we have our shortcut, so this becomes x plus 10 and x plus 10, which is x plus 10 quantity squared. And if you notice on these 3 examples, all 3 of them have become something squared because our factors are the same. This is called a perfect square binomial. And because it's a perfect square, this is going to hold true every single time. So if we look at number 4, if we take our 1 times 36 and get 36, what multiplies to 36 but adds to 12? When we think about 36, 6 and 6 add to 12 but multiply to 36. So this one is also a perfect square because it's two of the same binomials. So this becomes x plus 6 quantity squared. So if you notice, there is a pattern going on between our b value and our c value. So when we look at number 4, for example, if you look at that, the relationship between these two numbers is that 6. So how do we get that 6? Well, what's happening is we are taking that b value of 12, and if I divide 12 by 2, don't I get 6? And then if I take our 6 and I square it, don't I get my 36, which is what our C value is? So what's happening is we're taking our B and we're dividing it by 2 and then we're squaring it. So if you look at this one, number 5, what do you think is going to be our C value here? Well, if I take and I do 14 divided by 2, I get 7. So then 7 squared is 49, which means 49 is my C value. Okay, we're not gonna work with fractions today, so we're gonna skip number 6. But let's practice just factoring in general. Okay, so here we have x squared. Let's look at number 1. X squared minus 12x plus 36. So in this problem, we have a minus there. So we have to make sure we're careful. What's going to multiply to 36 but add to a negative 12? Well, 36, we just did a problem like this. We know 6 and 6 are going to give us 36 and 12. But because I want to add to a negative 12, I'm going to make those 6's negative because 2 negatives multiply to a positive 36. And when I add 2 negatives together, I get that negative 12. So this becomes x minus 6 times x minus 6, which is really x minus 6 quantity squared. Okay, number 2. If we look at number 2, we have x squared minus 16x plus 64. So again, watching and being careful of that minus sign. So we're multiplying to 64, but we want to add to 16. Well, 8 and 8 multiply to 64, but add to 16. But the problem is we have a negative 16, so I need to make both of them negative because 2 negatives multiply to a positive and add to a negative. So this becomes x minus 8 times x minus 8, which is really just x minus 8 squared. Okay, and number 3. If we take a look at number 3, we're multiplying to 4 and adding to 4. Well, if we think about 4, we have 1 and 4 and 2 and 2. Which one's going to multiply to 4 and add to 4 is going to be your 2 and 2. So because x is 1, I can do my shortcut and just write it as x plus 2 times x plus 2, which is really x plus 2 squared. Whoops. And that is how you factor perfect squares. Now let's do one where it's not perfect just to refresh our memory. So let's say I had x squared plus 7x plus 10. So here I'm multiplying to 10 but adding to 7. So 1 and 10 and 2 and 5. Well, 2 and 5 add to 7 and multiply to 10. Because our a is 1, we can write this as x plus 2 and x plus 5. Now because those aren't the same, we just write that as our answer. Now you could also write it, the order does not matter, so you could write it like this and it would still be correct. So that is how we factor. And that's going to help us complete the square